All right, we're going to look at problem 153, which deals with the definition of an angstrom. If we use scientific notation here, this problem doesn't present too much of a problem for us. And so this is an example of letting scientific notation do the heavy lifting. So we get a definition where 1 angstrom is defined. I actually use the define symbol here as 10 to the negative 10th meters. And so the first question is, how many nanometers are there in 2.5 angstroms? So what we're going to do is we're going to let our exponents here solve this for us. So 2.5 angstroms, let's use some conversion factors. So we have a definition here, so we want angstroms on the bottom and 10 to the negative 10th meters up top. Divided by 1 angstrom. Okay. And then a nanometer is 1 nanometer is 10 to the negative 9th meters. So our Greek prefix and our definition of an angstrom gives us some conversions. So these will cancel out. These will cancel out. And so I have 2.5 times 10 to the negative 10th, all divided by 10 to the negative 9th. Well, if I use my rules here, I get 2.5 times 10. So I have a negative 9 on the bottom. I'll divide that, it'll be plus 9. And so negative 1 meters, nanometers. So an angstrom is about 2.25 nanometers. And so the width of an atom is on the scale order of, let's see, slow light radiation, so in the infrared to radio spectrum. But it's a fairly small unit, and a nanometer is already 10 to the negative 9th. So, but our powers of 10 notation let us do this a little more quickly. So we're going to look at part B, which is how many femtometers are there in 2.5 angstroms. So 2.5 angstroms is 10 to the negative 10th meters in 1 angstrom. And now I've got to look up what a femtometer is. So I come to my list here, and 1 femto is 10 to the negative 15th. So 10 to the negative 15th meters in 1 femtometer. And so I have 2.5 times 10. Well, let's see, I have a negative 15 on the bottom. It's going to come up as a positive 15. So 10 to the 5th meters. So about 250,000 femtometers. I apologize. Femtometers. So there's 250,000 femtometers in an angstrom. So a femtometer is a really small measure. But notice how our power of 10 notation is simplifying our mathematics. Our rules of exponents here determine the exponent here, and this unit stays out front. Part C, we're going to go backwards now. We're going to look at how many meters, or how many angstroms are in a meter. So we start with 5.0 meters. We use our definition that there's 10 to the negative 10 meters in an angstrom. So 1 angstrom goes up top. 10 to the negative 10 meters goes on the bottom. The meters will cancel and we'll have angstrom, so we're going to have 5.0 times 10. Well, we have 10 to the negative 10 on the bottom. So when we divide it, our rules of exponent says that's going to become positive upstairs. So it's 5 times 10 to the 10th angstroms. All right, so this is going good. Well, here comes the kicker. We're going to look at light years. So we have 5.0 light years. And so we've got to get light years to angstroms. And so our first conversion will be meters. And so we have 9.461 meters. Oops, times 10 to the 15th. Gotta forget it. You can't forget the big numbers. Times 10 to the 15th meters per light year. And then there is 10 to the negative 10th meters per angstrom. And so meters cancel, light years cancel. I've got angstroms. And so I need to do a little bit of a multiplication here. So I have 5 times 9.461. And that equals 47.3. 47.3 times 10. Well, I have 15 upstairs. My rules of exponents are going to bring this up as a positive. So that's 25th angstroms. But that's not proper scientific notation, so 4.73 times 10 to the 26 angstroms. And using my rules of sig figs, what we'll want to do is keep this to 2 sig figs, so that 3 can go away. And there we have the number of angstroms that we have in a light year. So there's a lot of atoms we could stack up from one side of a light year to another.